Okay, here's some hints for the second homework based on a credit exam paper 2001. Now some of you have maybe looked through the homework sheet already, tried some of the questions and thought to yourself, can't do number 6, can't do number 13. Well, that's probably because in number 6 you're missing a diagram. So here's the diagram for number 6. The points A, B and C that you're trying to find are now indicated in this diagram. Also, question 13 is impossible without the angle 100 degrees. Okay, so if you were stuck on question 13 thinking that you couldn't do it, it was because I forgot to put in that angle of 100 degrees there. Okay, so if you want to try those now, for question 6 and 13, before you look at the hints, then obviously stop the video and off you go. Right, let's get to the answers now. First question is just your standard BODMAS question once again. So take your multiplication part first of all, get your answer to that, and then add it on to the 3.1. Nice and simple start. Second question, fractions. It's an addition, so if you deal with the whole numbers first of all, so the 3 add the 4 to give you 7, then deal with the fractional part. So now deal with the 5/8 and the 2/3. And you want to do your good old favourite kiss and smile method to get the new fraction here. Now when you do that, it's going to be top heavy. So you need to work out how many times the bottom goes into the top, and that's going to change the number at the front to 8, and it's going to change the fraction at the end. Number 3, seen a few of these now. Substitute the -5 in for the m, so we just end up with -5 squared minus 3 times -5. Shouldn't really be too much of a difficulty there. Question 4, first tricky question if you like. The thing that makes it tricky is the fact that you've got a fraction here with 4 on the bottom. Now we know how to deal with those. We multiply this number by 4, this fraction by 4, and this number by 4. Why do we do that? Because 4 times 2x, that makes 8x. The 4 on the front and the 4 underneath cancel each other out. So the second part of the fraction, the second part of the equation, sorry, is minus 3x minus 1. Now notice I'm putting that in brackets because it's minus all of it. Equals, and then the 4 times the 4 here would make 16. Now if you go through the rest of the questions, remove the brackets, tidy up, you will end up with x equals at the end. Question 5, find the gradient. Now we know the gradient formula is m is y2 minus y1 over x2 minus x1. So using this is x1, y1, and this is x2, y2, then we have t minus a over t squared minus a squared. Now some of you might just have stopped at that point. Some of you might have realised, wait a minute, the bottom here, that's a difference of squares. 2 squares with a takeaway sign between them. I know how to deal with that. I know to deal with that, I just factorise. Now if you factorise the bottom, one of these brackets will cancel with the top, and you'll be left with your answer as 1 over the other bracket. Right, question 6 with the added diagram now, trying to work out points A, B and C. Well, let's start with the C first of all, because that's the easiest one to find. The coordinates for C is just your number at the end there. So the coordinates for C are just 0 along and down 3, or 0 minus 3. So that's the easy one to get. How do we find A and B? Well, these are the roots. It's where it crosses the x-axis. So how do you find the roots? We put the equation 4x squared plus 4x minus 3 equal to 0 and solve. So if you factorise this into 2 brackets, the first bracket will give you an x equals, the second bracket will give you an x equals. Now they're going to be fractions. So don't worry about that, just to let you know it's going to be fractions. Remember, it's asking for coordinates, so you need to write your answer as A and B as coordinates. Second part of the question says, find the coordinates of the minimum turning point. So this point here that I've just drawn in the diagram there. Right, this point here. Now to do that, first thing we're going to need is the line of symmetry. How do we find the line of symmetry? You go back to these two x numbers that you had, and you add them together and then divide by 2. And that gives you x equals for the line of symmetry. And then if you take that x number and plug it back in up here into your starting formula, that'll tell you what the coordinates of the point are. Now don't worry because you found these things here to be fractions, right, because the x number at this point is not a fraction. So it's easy to substitute that back in without your calculator. Question 7. Simplify this here. Well, there's two ways we can go about it. We can either say that 3 goes into 24 8 times straight away. So we end up with 1 over root 8. And we know how to rationalise the denominator of that. We can times the top by root 8 and we can times the bottom by root 8 and proceed from there. Or we can do rationalising at the start. So we can multiply the top by root 24, then we can multiply the bottom by root 24. That will give us a new top number, that will give us a new bottom number, which we'll need to simplify to get the answer. So you can go through this question in whichever method you prefer. Number 8, one of these three-dimensional questions. We have to try and find the coordinates of f. Now, to get to f, if I was starting from the origin, right, from here, I wouldn't be going any in the x direction. I would just be going along there in the y direction and then up there in the z direction. So the answer I'm going to give for this question, and I'll just give it because it's you get it or you don't, is I'm not going any in the x direction. I'm going 5 in the y direction, and then I'm going 8 in the z direction. Okay, the calculator questions. Question 9. It's estimated 10,000 chocolates eat every minute. How much will this be in 2015? Well, 2015 is not a leap year. So, if there's that number in a minute, next thing I'm going to do is work out how many that is in an hour. How do you change minutes to hours? Times by 60. And then from hours to days, so we're going to times it by 24. And then from days into years, so I'm going to times it by 365. And if I do all that, I'm going to get a massive number, which if they then put in standard form, so times 10 to 3 significant figures. So only 3 numbers here, times 10, and then work out what your little power is going to be. Question 10, find the equation of the pipe. Well, first thing we need to do is work out the gradient. From the diagram, we know that we go 12 along and we go 4 up. So that tells me the gradient is going to be 4 over 12 or 1/3. Because I know that it goes through the point 2 here, then I know I can write down the equation straight away as y equals 1/3 x add 2. Okay, I don't need to do y minus b because I know the point on the y-axis. So there's your answer to your first question. Y equals 1/3 x plus 2. Now the question says there's another pipe, 3y minus x equals 6, and they intersect. Okay guys, I've just realised I made another mistake. Surprising. This y equals 1/3 x add 2. If I multiply all of this by 3, so if I do 3 times that, 3 times that, and 3 times that, that's going to give me 3y equals x add 6, which if I rearrange is 3y minus x equals 6, which you'll find is the same as what part B says. I have put the answer to part A in part B. The line in part B that you should be using is 4y plus 5x equals 46. So if you want to stop the video now and then do simultaneous equations on this new line, 4y plus 5x equals 46, and your 3y minus x equals 6, then that'll give you the point of intersection. Right, because I made such a mess of that, I'm just going to tell you the answer that you should be looking for. You should be hoping to get here that x is equal to 6, y is equal to 4 is the point of intersection. Right, number 11. Haven't made a mistake here. Two cylinders. We know the heights of them both. We know the diameter of one. We're trying to find the diameter of the second one. Okay, we're told in the question that the volume of the second one is the same as the volume of the first thing. So the first thing we must do is find the volume of the first cylinder. So V equals, now the formula for a cylinder is pi r squared h. So that's going to be pi times, now the radius is half the 6.5, so 3.25 squared times its height, 15. If you do that, you'll get an answer for the volume. Now we know that the volume of the second cylinder is exactly the same. So we therefore know that pi times r squared times the height of the second one, which is 12, must be the same as that answer that you've just found. Now if I take pi over to this side and take 12 over to this side, I'm going to be left with r squared equals a number, which then allows me to work out what r is. Once I know what r is, I can then find what the diameter is. Question 12, tan 40 equals 2 sin x add 1. Now you might look at that and think it's one of our all sin tan cos questions, and you'll be perfectly correct. However, this is a wee bit different to our normal questions because it's got tan and sin in it, and that might confuse some of you. What you need to remember is that tan 40 is just a number, and tan 40 you can find in your calculator, and it is 0.839. So I can just simply put that in instead of tan 40. I just got that from a calculator. Right, now I've got to try and solve this. So get the 2 sin x plus 1 on the left hand side, the 0.839 on that side, so I've just swapped them about. Now I'm going to take the 1 over, then I'm going to take the 2 over. That's going to give me sin x equals something, okay, and it will be a negative number. Then I can use my calculator to get x. Sin being a negative number, it's going to be in these two boxes here, which is 180 plus and 360 minus. Question 13, remember I forgot to give you this angle here is 100. The volume of a prism we should know is its area times its height, or in this case times its length, 5. So the question is basically saying what's the area of this triangle, where that side's 14, that side's 8, and that angle's 100. So I'm going to use the area of a triangle formula, half BC sin A. I'm going to plug these numbers into that formula to get the area. And then to get the volume, I'm just going to take that answer and times it by the height or the length of the shape, which is 5, to give me the final volume. And then lastly, number 14, calculate the size of the acute angle in the triangle. Well, here's the triangle. The acute angle is the biggest angle, so that's that one there. If I know the three sides in a triangle, that's an indication to me that I've got to use the formula cos A equals B squared plus C squared minus A squared over 2BC. So take these numbers, which are over here. Now, if you're not too sure which one's the A, B and the C, then this one here you could call B, this one here you could call C, and the one that's opposite the angle is always the A one. So doing all that, that should give you an answer for angle A. And that should give you an answer of 107 degrees. Right, you can work your way through to get that. Now part B, I know it might sound a wee bit confusing. The table leg is 70 centimetres long, calculate the height of the table. Well, let's draw the table back in. Right, it looks something like that. You've got that angle there, and the same on that side. Okay, we need to try and find, let me draw this a little bit better with an angle there, that's better. Right, we need to find what the height of the table is. So we need to find that distance there, h. Okay, so if I take that triangle I've just drawn, okay, that's the h that we're trying to find for the height of the table. We know that the leg is 70. We need to know that little angle in there. How do we know that? Well, we know this whole angle here is 107. We know that we're trying to calculate that height there. So if that's 107, that being a right angle for the height would mean that that angle in there is 17 degrees. So basically I'm going to use that right angle triangle in SOHCAHTOA to work out the height. So now naming the sides, that's the hypotenuse, that's the opposite, that's the adjacent. We're going to use the hypotenuse and adjacent, so we're going to use cos. So we're going to have cos 17 equals h over 70, cross multiplying gives you the height of the table.